Hey everyone, so in the previous video we were talking about atoms and I mentioned briefly molecules, but we don't actually know what are molecules. We only know that atoms are the smallest unit of everything you see around you, but molecules, if we're going to start the video with the answer itself, which I'm obviously going to explain in the next few minutes, molecules are just a combination of different atoms together. What do you mean by that? So, as you can see, I am showing right now the periodic table. The periodic table is a representation of all the elements we know in nature and the one we also made artificially in the lab. So, how do we read the periodic table? The periodic table shows the letters, and each letter, or two letters, represent an element. And as we said in our previous video, the amount of protons inside the core of each atom represents the element we are talking about. So check out what you can see at the top of each element. You can see something that is called the atomic number. The atomic number is equal to the amount of protons inside the core, which is equal to the element itself. So for example, we have hydrogen. Hydrogen is the smallest atom we know of. So hydrogen, which is 1, has usually a single proton. Let's say take here for example. A single proton inside a cell and an electron, let's say, around it. Even though we agreed already it's an incorrect way to show it because the orbitals represent the electrons in space where it is statistically likely to be. But just for the sake of this example and to understand what molecules are, I'm going to show the incorrect way of actually represent an atom and orbitals. So let's assume we have one proton and one electron, and we have H atom, which is, of course, as I said, it's an hydrogen atom. And now let's go, for example, to oxygen. Oxygen is right over here in the periodic table. It's being represented by 8 NO, and the 8 means that we have 8 protons inside the core of the atom. So if we paint it, if we illustrate it, we will see that we have 1, 2, 3, 4, 5, 6, 7, 8 protons inside the core and a different amount of neutrons as well, but for the sake of example I'm not going to draw them. And we have the electrons around them. But something important to understand, which obviously I'm going to explain in future videos, is that also electrons have different amount of electrons you have around each atom. So from the periodic table you can see the rows. So you have the first one, the second one, the third one, the fourth one, the fifth one, etc. Each row represents the amount of electron orbital levels we have of the following elements. So hydrogen is in the first row, which means it is only going to have a single orbital, a single level of electron around it. However, as you can see, oxygen is in the second row. What does it mean? It means that oxygen has 2 levels of electrons. And don't worry about it, you don't need to know about the levels of electrons right now. Just know that from the periodic table we can get a lot of information about many things about the elements. It makes a lot of sense to order the following elements in the following periodic table, and in the future you're going to see that the size, radius, amount, number of covalent bonds, the electrons, everything can be deducted from the periodic table. But for now, just remember that the amount of electron levels can be deducted and assumed from the periodic table. Now, we have 2 atoms right now. We have the hydrogen atom, which has a single level of electrons, and we have the oxygen, which has 2 levels of electrons. But why would we really care about the number of electrons and the number of levels of electrons we have around an atom? Does it really matter if we have atoms or molecules? So yes, it is. What we can assume from the position of the elements inside the periodic table is also the amount of covalent bond, and if you don't know what covalent bond, don't worry about it, we will cover it in future videos, is the amount of covalent bonds each atom can create with each other. And if you remember from the beginning of this video, we talked about the fact that molecules are just atoms that are being combined together. So, if you watch the periodic table and you will go to oxygen, for example, you see that oxygen is in the 1, 2, 3, 4, 5, 6 column of the periodic table. What does it mean? It means that oxygen on the latest, the farthest electron orbital contains 6 electrons. And as you will learn in the future, don't worry about it right now, the octet role, as you can hear from the word, octet means, octo means 8. You need to have 8 electrons in the outer shell, outer level of electrons, in order to complete complete states, in order to reach a complete state. I know it's a lot, don't worry about it. All you need to know right now is the fact that in order for an atom to be complete, to be thermodynamically stable, physically stable, is to reach 8 electrons in the outer shell of it. And what does any atom can do in order to complete this octet role is to steal or to give electrons to a different element or the same element. So what can we see right here? So if you go to oxygen, which has 1, 2, 6, 4, 1, 2, 3, 4, 5, 6 electrons in the outer shell. And oxygen would really love to have 2 extra electrons. And hydrogen, as you can see, it's in the first column of the periodic table. And hydrogen contains a single electron of the outer shell. So what can we do? We can take the hydrogen and we can give the electron to the oxygen. So as you can see, if I will take it, I can give oxygen an extra electron. But now we have only 7 and we need an extra one. So what we can do is we can get another hydrogen and we can connect it to oxygen as well. And what do we get? So now we have 8 electrons in the outermost electron level, the electron shell, and we reach an electrodynamically and thermodynamically stable state, and we reach the octet rule, and we also have a molecule because we have 2 hydrogens and 1 oxygen, which all fit the octet role and all share the same electrons. And when we have a couple of atoms and all of them share electrons together, we get a molecule. And which molecule is 2H and 1O? And we know it as H2O. H2O is water, is a water molecule. And we will see it a lot in the future. And we will see it in many different reactions, the creation, the destructions, and the usage of water molecules in a lot of biochemistry pathways. And I hope it made sense. This is how we create molecules from atoms. So if you have any questions for me, please make sure to comment them below. I really hope this video made sense because we are working really hard to create this kind of videos and to explain the fundamentals of biochemistry in the easiest way as possible, because I believe many different sources have they have a very good source to study from, but the problem is sometimes that they assume that you have a specific level of knowledge and then they just continue from it. And what I'm trying to do is to build and to help you guys to gain the very solid foundations of the knowledge, to understand how you have molecules that are made from atoms. And the next lessons we are going to understand how molecules form fatty acids and proteins and a lot of different things. So I really hope it made sense. I will see you in the next video.